Ciao, Liam in for bear. AI agents go blank between sessions. Agent memory claims to fix that. 2% recall, 53 MCP tools, no database. Don't take the README word for it. Read the code, here's the move. The repo rohic00/agent memory, TypeScript version 0, 928 Apache 2. The claim is 2% recall at rank 5, 92% fewer tokens, 0 external databases. That last one, 0 databases, is either a serious constraint or a serious design decision. We will find out which. 39,000 lines of source. First signal, where does the code concentrate? Trigger/API.ts is 223 lines. CLI.ts is 3049. Then a cliff MCP/server. TS at 773, then everything else under 1,000. That gap between the top files and the rest is the first clue about where the system lives. Second signal, the call chain. Index. TS registers the Roman 3 worker and routes everything downstream. Every incoming observation flows through functions /observe. TS deduct privacy strip vector index and terminates in API. TS, LOC and call chain point at the same file. That is not a coincidence. Now read the file that feeds into it. Observe. TS 345 lines. The imports are the architecture, privacy strip, deduct map, keyed lock, autocompress check, vector index add, no database client, no network call. The entire memory pipeline runs locally in process. That is the system. Third signal, churn. The project launched February 2026. April was the surge, 221 commits in 30 days. May added 165 more. 467 commits in 5 months. Velocity this high, this fast, means the core structure crystallized under pressure. That is where you will find the load-bearing decisions. Dependencies explain why API.ts carries so much weight. The engine is Roman 3 SDK, 3 primitives, nothing more, no database client, no cache layer, no external queue, there's nothing to offload to. API.ts is fat because it has to be, it is the infrastructure. 0 external databases is not a marketing claim, it is a structural fact. The method LOC shows where code concentrates, the call chain shows where every path converges, churn shows where the work piled up. In agent memory, all 3 signals point at the same file. Find that file and you understand the system. This move works on any repo, not just this one. Agent memory 39,000 lines, 53 MCP tools, 0 databases. The load-bearing file is triggers/API. TS 223 lines, every read, write, and hook. Lock, call chain, and churn all pointed there. Read the 3 signals, find the load-bearing file, understand the system. Here is the blank problem. Session 1, a user mentions a preference. The agent calls memory save, that fact drops into the store. Session ends, context wipes, the agent is blank. Session 2, same user, same question. The agent calls memory recall, the stored fact comes back, answered correctly. That is what 2% recall means. Your turn, take any repo you're curious about and ask Claude this. Run WCL on the source directory and rank the top 10 files by lines of code. Then trace the import graph from the entry point to find where all paths converge. Tell me which single file is the load-bearing one, and why. That prompt does in one pass what this video did across 11 beats. How to read any codebase brutalist at Nick Bear Brown, Liam in for bear.